Hello everybody, welcome to day 26. I am hoping to conclude the scripting stretch today. We'll see how we do with that. So, one super quick note about factoring, refactoring, and defactoring, since it's come up in conversation with someone. And let's see if I can keep it in 5 minutes or less. Now, we have said before that you can have a function of something, and you can have in programming a multivariate function. So in that case, what you have here, these are called arguments. This is true in both math and programming. This is the actual flag of the function, and from that, as we said before, the intended outcome of a function is to get some result, and that result might be in any domain. It doesn't matter all that much right now. So sometimes you will hear people talking about refactoring, very rarely about factoring and defactoring, and that is actually also a mathematical thing, and refactoring is one of those things that is almost always done in a dangerous way. So factoring in mathematics is a pretty simple concept. If you have something, you want to extract its factors, and there might be many of those, but in principle, you know, the two factors of a factoring of 24 will be 6 by 4. So if you think about these in terms of components, this is basically going to be equivalent to your result, and you are factoring into however many arguments you feel the need to. So that is basically what factoring something. If you have, in our case, something like what we're calling our main for now, and the code itself doesn't really matter. We've done it before. As we identified something that was interesting, and it had a clear input and output, we moved it to some function, like deleting the guide, finding the key objects from the containers. This might be mistaken for a keyframe, but so that is basically called factoring, because you're taking something that was part of a whole and you are extracting it into a factor or multiple factors, so you might extract it into multiple functions. Now, the idea of refactoring something, the key idea of it is that the number, types, and order of arguments, this is called the signature. This is the signature of a function. It should not change. Your output should not change. So if a function's input and output are unchanged, that function is typically and quantitatively the same. So very often people say, I'm going to refactor some code, and what they do is actually rewrite it, because they change the nature of the signature, or they change the number of arguments, or their order, or the result changes slightly. You are not refactoring if you change the signature or the domain or the codomain. Let's make that clear. Now, if you are taking something, if you're taking a whole and extracting components, that is when you are factoring. So in the case of a function like ours here, we might have a couple of things that we're interested in this main. We are doing something to get the track plugs, and something else to get the active plugs that we're genuinely interested in doing work on. If I were to extract these two, that would be called a factoring. Now, there is also a thing called defactoring, mistakenly sometimes, well, not really mistakenly, but sometimes called inlining or hard inlining, where maybe I have a function like this one, which is probably occurring, somewhere here. If I take that, and instead of having the function call here, I replace these with the expansion of it, so with the code that is actually in the function, that is a defactoring. which is pretty much, I mean, at this point, I'm sure you guessed it, is pretty much equivalent to taking, let's grab yet another color. It's pretty much equivalent to taking the two factors and bringing them back together into the actual whole. So when we talk about factoring something out, or we talk about refactoring or defactoring, that's what we're talking about. Hopefully this is a useful bit of knowledge. I just wanted to establish vocabulary now. And hopefully that also makes sense. You never see it explained. Like people, you get inducted into programming at work or something like that. People start talking about refactoring, and then it becomes modifying existing code is refactoring. That's not what it is. There's a very specific subset of these operations that constitutes refactoring. If you're changing the nature of a function, you are not refactoring, you're rewriting and possibly doing damage more often than not. Now, with that said, let's this is gonna get pretty unwieldy to work with, and I was just working on some code before, so now going in presentation mode is a bit of a shock. And I think the text size is working so far. Chat, let me know if this is readable. So what we want to do is factor out the extraction, and the first thing you want to do is find what's coming in. Now I'm hoping to talk a little bit less and do a little bit more this stream. You might have to bear with some and has. So this is iterating over plugs, and then we're getting the subplugs. So it seems reasonable to do something. We could prototype a bit here. This is why I keep a snippets page around. It seems reasonable to say that we want we do care about origin and guided, I guess, and then we do care about the ones we're tracking. So let's say they were calling these tracker subplugs from array plug, doesn't matter, it's tracker subplugs from plug. And the expectation is to go and get a plug name. Why am I doing that? And guided. In fact, this is a constant. So we're gonna assert that plug is compound. So these will, this is a property. So this will basically fail if this is not a compound. And we're gonna assert that plug num_children is 2. Then what we are doing here, this seems legit, so let's do as a copy and paste job. And so we are moving that. We do care about some consistency here so that we don't go nuts on that. Chat, give me a sign of life, please, and because I've occasionally lost sync with the chat where I wouldn't see anything written. It's a Twitch thing. So anything will do. Just move a table or something. Move the thingy on the board. So plug key, partial name, rsplit. So this is good. Track plugs dictionary, plug key, plug copy. So at this point we are inside the scope of a function. What does assert do? It's a good question. Assert is basically saying this is gonna be true. So you can put an expression in here and that will return true. You could put something that returns a boolean here, so plug is compound will return true. Oh, zesty. Someone put it a plus and said you asked for a sign. Well done. So assert is basically saying this is bound to be true, otherwise I am gonna fail. Let me see, Python console. So if I do something like this Python, then nothing is gonna happen. If I do assert false, you will get an assertion error. So it's a way to, normally it's more of a debuggy testing thingy. It's a way to shield your code from errors. That is pretty cheap. If you don't want to implement exceptions and detail them, you can also give it a message. So something like that. That way you will know what the assertion is that failed. Probably a good question to answer now. Don't overdo it. Assert is pretty cheap, but don't overdo it. But in this case, when you start factoring, you don't know if you're gonna forget what this is supposed to do and what not. It's worth doing a little bit of shielding work. Now in this case, we are gonna be returning this dictionary, so that makes the plugs at risk of volatility. So we are gonna keep the copy, which makes them safer. And we should be able, and if you want the final assertion to be super sure, you could do something like assert that subplug is known as, these might be property or a method I don't remember right now. So you could do that and basically build further shielding around the ends of the function. I don't care for that much because we've tested this enough to know that this is fine. So this seems like a good enough thing to go by. So find the ends of where you're working when you're doing something like this. We were going from lm plugs. We're building the dictionary. Oops, the dictionary in here. So at a glance, for the lm count, the lm plug we want to find, this is what we are replacing with our function. And let's make it clear that this is in there. To a couple bookmarks just in case. So my objective here is for no behavioral changes in these whatsoever. So we start from the lm plug, and we want to keep this name to avoid disruption. So this becomes, what do we call it? Tracker plugs, yeah. And tracker subplugs from plug, lm plug, and these should all go away. Two panel couples. Okay, this is where we're appending there. We might even do a map. I would like it more than a for loop, but maybe not just yet. So the expectation here, let me make sure, oops, that, yeah. So I'm modifying 25. I wanted these to be 26. Bugger. I'll reinstate 26 later. So, okay. Now, let's go back to Maya for a second. Open our trusty charcoal. Keep this file in the editor. Yes, actually. I should be able to just save these and it will reinstate things where they were. Maybe. Nah, let's not do it. Oh, I'll pull it from Git. So, no. Okay. Alright, let me go and dig up the code itself. Didactic. This is what we want. So the expectation here is that nothing should have changed. At the very least. So yeah, we're still in the game. Now the other piece of defactoring we can do is a conversion of the tracker from the track plugs. So these should probably be called tracker plugs. I was fighting with the names before. Tracker plugs seems good enough. I was calling them tracker subplugs. Yep, I'll take it. Now, this is the population. So I'm not gonna go into maps just yet. Now, working on the actual source plugs to the track ones. Should probably add Docker to these, but I mean at this point our code base is pretty small. We shouldn't have issues. Hey man, someone joined chat. Okay, so active plugs. I don't mind these actually now. Active plugs expects a tracker plugs dictionary, so that seems reasonable. And that also seems reasonable. So we could go and do that. That will say, look, this is expected to be of type dictionary. Getting the keys. Yeah, maybe. And we're gonna assert that for each key in these, we're gonna assert that the key is the tracker dictionary, so we're sure that we're getting something meaningful. Now we can't check the contents because, as we said before, some of these could be none and it will be reasonable. Now, those dictionary keys are gonna be that. And I reckon I don't want constants in here, but I don't want this to be a constant going out because that will become module constant. That is where pain lies in abundant amounts. It lies in weight, pounces on you. Don't want to go there. It's a dark place, it's scary. But this seems pretty reasonable. These could become a constant, I guess, but we can leave one constant string in there. It'll be fine. We're not micro-optimizing this stuff right now. And likely never will. So the next thing is, man, I was hoping to get more done this stream, but factoring and refactoring and stuff like that is pretty important. So what we calling these? It's okay to call something like return dictionary or something like that. And I gotta be careful about how I spell these things because it gets pretty funny pretty soon. At least it's okay to me, because all I'm expressing is the fact that this is the one that I intend to return. If there's more interesting information to convey about what the function does, it should be in the function documentation. That is my take on it. Feel free to leave it or to take it. Now this is also a dictionary that's going to be returned, so we're going to do the plug copy dance to sanitize them, and we're definitely going to do red dictionary at that key equals that. Then at that we're gonna go, so the tracker plugs dictionary is the one that we are, no? Okay, because it's not refactorable. Funny. All right, whatever. Now, so we are gonna do that if the key is not none. Should probably replace that key. Oh, we had a... No, we did not have a mistake in there. For a second I saw the double here and I thought... I noticed the double here and I was like, were we getting the origin twice? But no. So the one we want here is gonna be that one. And this is where... Yeah, the code is still inside. So we could inline the if in here and go we're gonna do that only if not none, but I don't like it beside the fact that the line becomes, you know, a million characters wide. So we're gonna do that. I mean, I don't like it in this case. There are very good uses for something like that. Now, if that is the case, the other thing we're doing, we could put a couple assertions in there. So we say that this is where we want to error. So this might be a good place for assertion instead of an if. Assert that this is not none. Receive the none, and this is the guy that that is working. Pass source. Get it plug source. So this is all legit. Now this one, yeah, we also want to copy because this is part of the return. That way, if we decide to change, like this is, you know, losing a little bit of readability, legibility, if you want to be correct. And if anybody say that, I will wholeheartedly agree. But the main thing is that as we're factoring this stuff out, we want to keep consistency across multiple functions. And that is where it becomes unreasonable to have, I reckon, to have something that is always typed in. And you need to start, like if two functions have a commonality that is supposed to be constant, make it a constant, regardless of whether this represents an optimization or not. Sorry for that. Now, active plugs dictionary is our return dictionary. So we have retrieved at that point. The best thing about kids these age, babies these age, is the noises they make. Return dictionary. We say that that's guided, so we want to get guided and then get the source. Woof. So if it's not null, yeah, fair enough. This is an acceptable fault tolerance because we want it to be none if nothing was connected. And then we can return the return dictionary. So if we get ourselves that, plop it in here. This is begging for documentation, but I want to move a little bit faster because I don't want to spend weeks on scripting, like instrumenting the stuff. We need to go back to the rig and show how to instantiate a component multiple times, and we're doing this to make our lives easier. When it starts making it harder, you should reevaluate your priorities in your rigging life. So this is good. This is still good. Now actual source plugs to the track ones. Okay. Going from tracker plugs to the active ones. So I'm curious, chat, please entertain me because this is a lonely job otherwise. How interesting has it been having this stretch of scripting? Is it stuff that's actually useful? Is it entertaining? Is it not? So guided source, active plugs dictionary. So the theory is that we can replace all of these with active plugs from tracker dictionary and give it the tracker plugs dictionary. So again, if this is a proper factoring, nothing should be changing here because we found boundaries inside our code that have a clear domain and codomain, which means we could plop a function in there. So again, the expectation is that these should just work. Continue reloading, yes please. So this is 26, yes. And guided source none, which is probably true. So we're saying, so far so good. So it seems the general tone that I've got from messages and now in chat is there's not much of these on the internet, so it's good to see it. It's one of the problems I have with the stuff that's out there, and there's a couple exceptions I'm told, but I haven't seen that material, so I can't endorse it and I don't want to mention it. But in general, you see very little OpenMaya out there, and a lot of it is not really close to the Maya mechanics. So I wish I could just point people to something else and focus on the rigging, but it seems like we don't have that luxury. So the result we got is, I'm looking at the tool parameters here, which is the config parameters, but I should be looking at the tool parameters. Let's make sure that what we have is correct, because we're getting it's so hard to work single monitor, but at least I'm full res. The guided source is none. That seems possibly incorrect. What did we say the guided source was going to be? So a problem with doing these in stream form is that you have limited time, you're constantly catching up to what you were doing. And so if it's none, I can't do that. Don't do these at home. Don't do dodgy try excepts like these. Name for plugs is a method, for other things it's not, I believe. Just continue in that case. Dict object has no iter. Oh. So we have origin, guided leg global. So that's correct. Up at global, offset. I thought we said, so this is the guided source. I think the expectation was that we would have got active plugs dictionary. Guided source equals oh, there you go. See, this is why you should be very careful when you're doing this kind of stuff. So origin, we get the Yanko global offset, and from that we get the guided source leg global, blah blah blah, word matrix. And here we get the matrix, which I forgot we did. I thought, you know, I would have expected the word. So very good. Whew. I was very concerned there for a moment. So we're good here. Now the next thing to do is we don't need these any longer. In the do nothing case, and we could map these and basically make it branchless. And if you're wondering, branchless code is code that doesn't have if else. It doesn't, or other things that will steer the code down some paths and make them hot and make some other paths in the code evaluation code. Branchless code is code that it doesn't mean it always sort of evaluates, but it's code that basically picks what to do in other ways. And it's super common, like in functional programming, in SIMD development, like vectorization and stuff like that. You don't find it a lot in Python, and that's okay. We don't need to concern ourselves with that. But it's not a bad idea to be a little bit more statement driven and just saying, I know that these equates to these couple of parameters instead of having many ifs and else and elifs. I am sorry again for that. Morning is scratchy throat time. Definitely gone over. So let's say we want to do at least a couple cases. We really have to. Disconnect is the only one that's gonna occur for us. So, now, do I have commands in here? Yes, we do. Now we're gonna use OpenMaya 2. Like when you're just inspecting things, it doesn't matter at all. But if you're modifying things with OpenMaya 2, you are basically messing with the undo stack, because OpenMaya 2, unlike commands, doesn't undo automatically. Actually, what's let me check. So let's keep our undo for now. Let's use a command again. I want to show the the OpenMaya way of doing this, but seems premature to lose the undo. So disconnect attribute wants the full path, and this is where partial name becomes very useful. If it's disconnect, we know that this is true and that this is true. So we're gonna keep the names hard baked, but eventually we should be referencing the same constants from up there. Then the other thing we'll want to do if we're doing a full swap is handling the opposite case, where the origin is none. Sorry, where the guide, anyway, we'll figure it out. So disconnect, we're saying that the origin is none, which is correct, because in the active plugs dictionary, the origin, now we need to make sure of this though. The origin of this should be empty. How would you handle the undo outside of Python plugins index? You need a custom command wrapper, basically. I don't know if we'll get into it. You basically create, you have a dummy command and you create instances of that command with a chunk of data on the fly. It can get a bit involved. Doing a plugin is much easier, although it has more CRUD to it. So disconnect after that word matrix. We did a couple prints which will be useful. Ankle controlled word matrix. So we're looking at what here? Oh, that's funny. The disconnect actually gives you the full extent of it. So that's the guided source, which seems correct. And the leg global, ankle global offset, and that's our guided. So this is the kind of stuff for it. You gotta be a little bit careful. So in our case, it's should be guided source from guided, because this is the guided source, this is the guided, so that seems to be the reasonable disconnect. And so active plugs dictionary, guided, that should get us a plug. Is it partial name? We'll want to include a few things. And active plugs dictionary guided source, because if you're not careful with this is the kind of place where you can go crash. That should be a valid plug, because we already asserted, well, not asserted in here, but we already stated this can only happen if. So disconnect after. Guided is never none, basically, and guided source is not none. So that seems reasonable. I would expect that to work now. I do need to check the docker super quick. Whoa. And we want to include the node name. Useful attribute path might be, so include node name and useful attribute path. I reckon he's gonna be compliant to the command. So both of these true. Now, what was the syntax of the command itself, actually? Disconnect. I'll need to look at the syntax of that. Because we're starting to pass in arguments. Oh, no, never mind. I'm stupid. So these are actually for the partial name. This is begging to be removed from here because it's becoming impossible to read this stuff. Name them unambiguously. We don't care about these, like we don't care about what they represent. We've already validated all of our assumptions. Well, we're about to. We only care about what they're being used for in this case. So don't need these, don't need these. Almost there. Someone has an example on GitHub about creating npx command on the fly. Someone told me that someone I know was doing it. I don't know if their work is public. I will have to check that. So mail attribute. I would like the Python one, please. There you go. Source attribute, destination attribute. Yes, but whatever. Strings represent object names. I'll have to try. This is likely to mean one string with a space in it. This is the problem with some of these docker. Connect, disconnect. So in here they're using two separate. Let's try it. And it should be in string form, knowing. I practically never use commands for this kind of stuff, so bear with me. Now, with something selected, put in your bets on whether it will work or not. It's done nothing. So we're clearly not doing anything interesting here. Are we in disconnect case? We gotta check that. Man, I was hoping. I hoped in vain. I must have forgotten something. No? You disagree? Okay, I need to set that. Sorry, like boring work. I got lost in the thoughts for a second. I would have expected this to work. We're clearly missing something. It's like we're tossing around a few names willy-nilly, so... what is it? Sure. Let's give you a silly name. Oh, no. This should be connect. I don't know. I thought I auto-completed. I clearly didn't. So... whatever. Debug printing, the joy of it. And come on. Yes, please continue reloading. So we have a swap and we have a swap. Okay. This connect should mean origin none. So we have origin is not none. And active plugs is not none. Okay, that we clearly sorry, we clearly have a mistake in here where the origin is flagging because we're in the wrong case. So we might not be too far from what we want. Now, where is the quickest way to get the origin? So, if origin is not none, oh, that's a mistake. So this is our tracker dictionary, and we're saying if the origin is not none, we know that origin as a plug coming from the tracker dictionary, like this should always exist. So what we want to do is convert these to make sure that it is a destination. There you go. I think that's that might do us. So if it is a destination, then we find it true. So what was happening was probably that this was a null plug, and we had no reason to check whether this was null or not. Hopefully that makes sense to you folks. It does to me. Is destination is just saying, hey, is this connected and is it receiving something? And let's run that. So we're still in swap because I haven't reloaded, which is fair enough. Type error. Okay. So we're now in disconnect. That is very good. That is what we're hoping for. Now invalid argument. Expected arguments of type. Oh, you want a tuple? I will give you a tuple. Sure. I don't mind if you want a tuple. That seems like a not unfair request of you. No? Invalid argument 1. Ah, does it want the node and the plug? This is why I hate commands with a passion. So before it was telling us invalid argument 0 maybe? Where is that? No? You're not gonna show me anything? There you go. Invalid argument 1. You people that use commands more often than I do. What does this thing want? Does it want a tuple of the node name and the plug name? Anyway, let's have a look at that and then call it. And someone was asking, what font am I using? I would have to check. Maybe it's Liberation Mono. I don't know if it comes with PyCharm or if it's a Windows one. Anyway, commands. Let's look it up. So disconnect Thatcher, sphere R and cone R. So this is taking, this is the format I had it in. Node2.adder, not name.plug. Yeah, it's what I thought. I must be, let's have a look. Oh, that. There's a comma in there that should not be in there. That was my expectation. That was the first thing we had. It's possible that we just, let's have a look. More print debugging. So Control D is duplicate. And here for me it's delete, but and continue here. So vector control M, WM. It's using the short name, and it's not giving you the index. Partial name is at fault here, or rather my use of partial name. Use full attribute path. What does that give me? Use long names? Sorry. Okay, so it seems like Maya's complaint was legit. Now the part that bothers me is that it's not catching the index here, which might be trouble. We'll figure it out very soon. Almost there. We don't need these anymore. We might want to... So recommendation, don't keep around, comment the code. If you're prototyping and you have something that gets you a quick debug, do it. There is no connection from Enco Global Offset because it's the other way around. Really? So... Sure, in this case, like, I gotta remember to undo these, but seems like the order is different. Yes. Bang on time. Exactly on time. So our first assumption, we debugged a little bit, but let's undo these ungodly first and second having opposite meanings. Because that is how kittens die. You kill a kitten every time you do something like that. And we should still have a proper undo. Yes. Alright, 1K is covered. You can run it. Whoa. You can run these. And the guy has no effect. Now, the other thing we need to do is... Can we do it in less than 5 minutes? Probably not. For this to become a proper swap, as this gets removed, it also needs to be connected in the origin so that then we get the opposite behavior. With this is empty, this has something, it should trigger connect. We do have the origin. We could be brave. Anyway. So, next time, I guess. But, this has come to something. I'm happy with this. I'm not going to push my luck. Do we have questions? I'm going to give it just about a minute. And if there's nothing, I'm going to call it here. Because when something is working, like when you got somewhere that has a definite like demarcation where you go, okay, this is done, I need to do something else, and you're bang on at the end of the stream, that's when you do not do something else, hoping to do it in 2 minutes. It's a lesson I've learned the hardest way. And if you're not seeing these, don't worry over much. This code will be available on GitHub in Didactic as usual. Oh, you should have errored. Message attributes of no data values. It doesn't matter. No questions, it seems. Is the stream catching up? Yeah, there's a fair bit of delay. Anyway. Alright. Calling it here. Let me see. Unless I'm losing something in the chat. Alright. We seem to be good for now. We're calling it here. Thanks everybody for watching. We are gonna take a break from the scripting stretch tomorrow, and there's gonna be a redux because I did a stream 13. I kind of like slipped into talking about functional, and I just don't want to do like it wasn't a poor job. I mean, and people liked it, but I don't think it does justice to the subject. So I'm intended to do an edited version of it. I completely overrated my ability to use what little spare time I have to do it. So I'm gonna do a Redux stream tomorrow. We're gonna do functional rigging proper. And if you're watching this on YouTube, that's gonna be episode 13. So it'll be back in the playlist. You might have seen it already at this point and wonder why there was some discontinuity in it. If you are following the stream instead tomorrow, it's going to be functional rigging. Cool. Thanks a lot, everybody, and I'll see you the next time.